All right, let's continue with 1-6. I think this is example 3 in the book, but you're not really following along too much in the book anyway. But if you want to write it down, you can. It's example 3. So let's do an example. Let's write this down. 3x to the negative second. Again, we're sticking with negative exponents, and we're going to do a combination after this example anyway of negative exponents with fractions and that kind of stuff. Actually, we might even get some fractions on this one. All right, there you go. And it says to simplify is what we're trying to do. You're not really solving for anything, are you? You're not trying to find what x is equal to. All you're trying to do is take this and then just work it out until you come up to its simplest form. On these, they always want you to put the exponents as positive exponents. All right, so they don't want you to leave it as a negative exponent. So if you have a negative exponent, it's on the top. Where do you move it? To the bottom, and you change the sign of the exponent. Okay, so that's one of the criteria that they give you here. So let's see what we got. We got 3x to the negative second times this whole parentheses right here. A couple ways you could approach this, but let's do it like this. Let's keep this 3x to the negative second the way it is. I mean, we could have put it on the bottom, this x to the negative second. We could have stuck that on the bottom, but I'm just going to go a little bit at a time here. So let's just do one step at a time. So let's do this stuff right here. All this parentheses, all the stuff in the parentheses right here is being squared. So let's take everything in here and square it. So let's see what we have. We got 4 to the negative first, but what's going on here? It's being squared, isn't it? All right, so what's the rule? And I'll put a little dot here to show multiplication. That's right, you multiply the exponents together, right? Okay, so when it's negative first to the second, you multiply. So what is it? It's 4 to the what? Negative second. Good. All right. And then we have another times. Then you have x to the negative fifth, and it's to the second. All right, and the same rule applies, right? You take the exponent, you multiply it, and so what do you get? You get x to the what? Negative 10th. Okay? Now let's take a look. Well, this is all multiplication, right? So we've got the same bases. We can multiply with the same base. So if you wanted to, and I'm not even throwing anything on the bottom just yet. All right? Let's see what we got. You can't really go 3 times 4, can you? Because this is 3 to the first and this is 4 to the negative second. You can't really multiply those together. So we'll just keep the 3 there. Let's multiply the x's, though. We can multiply these together. Can't we? And again, there's all kinds of ways you could approach this problem. I'm trying to look at it as the simplest way. I don't know, maybe some of you might want to do it a different way, but we're going to do it like this. I'm going to multiply the x's together, so you keep the base the same. Now, what do you do with the exponents when you're multiplying the bases together? You add the exponents. Good. So negative 2 plus negative 10 is negative 12. So I'm done with that. And then I have to write 4 to the negative second. Okay, that's being multiplied. See what I did so far? Basically only 2 steps. I squared everything in the parentheses, and then I multiplied these same bases. And I really didn't do anything else, did I? That's all I've done so far. Now, we don't want to keep it like this, though. There's really nothing else you can multiply together here. But what do we have? We have negative exponents. And what did I say earlier? You have to do what? You have to make sure that they're positive exponents, right? So what I'm going to do is I'm going to take this. That's a negative exponent. I'm not going to take my 3 and move it to the bottom, am I? Because it's 3 to the first. So it's fine on the top. I'm going to take this, right, chuck it to the bottom, and I'm going to take this and chuck it to the bottom. Now, why would I do that? Because you got a negative exponent. If I have a negative exponent, I want to take that stuff and move it to the bottom to make it positive, correct? And we're almost done. So really, what's left on top now? Just a 3. 3 is left on top. This x to the negative 12th goes to the bottom, and it becomes what? X to the positive 12. Okay, you see that? We took that, threw it to the bottom, and changed the sign. What about this? 4 to the negative second. You throw that to the bottom, and that's what? 4 to the second, or 4 squared. We can do that in our head, though, can't we? What's 4 squared? 16. And there it is. That's all you can do with it. You can't do anything else. You got all positive exponents, right? 3 doesn't go into 16, so you can't do anything there. You can't cancel anything out. So you just leave it like that, and that's your answer. Got it? All right. Let's do another example. This one might be even easier. It's supposed to be a 3. Sometimes when on this little pad thing I'm writing on, my 3's don't look so hot. Alright, here we go. Let's simplify this thing. This all says simplify. First of all, I'm going to do this. 5 and 10 is being multiplied, right? So 5 goes into 5 once, 5 goes into 10 twice. So we got a 2 on the bottom. Now what about this? We could subtract them from each other. Remember that? Keep the base the same, subtract the exponents. Or I could do this. This is how I'm going to look at it. I'm going to take this one. You could take this one, this m to the negative third, move it to the bottom, right, to make it positive. Then you could take the m to the negative fifth and move it to the top. But you don't have to do both of them. Let me show you why. Because if I take this, and if I chuck that to the top, make it m to the positive fifth, look what happens when I multiply those together. That's going to be positive, isn't it? So I don't have to waste my time and take this, chuck it to the bottom. I'm still going to get the same answer either way. Okay? So let's see what we get then. On the top, what's m to the negative third times m to the fifth? Add the exponents, right? So it's m what? Squared. Wouldn't that be the same thing if I would have moved that m to the third down to the bottom? Right? Because I would have had an m to the fifth on top, m to the third on the bottom. It's still m squared. Either way you do it. But that just kind of saves you a step by doing it that way. And what else is left? Oh, don't forget the 2. That's on the bottom. And that's it. That's all there is to it. Starting to get the hang of this? Maybe?
Did you cross out m to the negative fifth?
I moved it to the top. That's why I crossed it out, because it's not on the bottom anymore. I see the arrow? I moved it to the top, and I crossed it out because I moved it to the top. There's not 2 of them. There's not an m to the fifth on the top and an m to the negative fifth on the bottom. I took it and I moved it. That's why I crossed it out. You don't see that? Okay, because you're looking confused. Your eyebrows are going like this, like trying to figure out what's going on. All right, so that's what we did. We took this, we moved it to the top, so we got rid of it, right? Because I moved it. And then there you go. All right, let's do another one. All right, this one's kind of the same deal. All right, just a couple extra things here. First of all, let's take a look at the 12 and the 8. Does that simplify? Does anything go in, divide evenly into 12 and 8? Yeah, what's the biggest number that divides it? 4 does. 4 goes into 8 how many times? Twice. And 4 goes into 12 3 times. Now let's take a look at the p's. I got a p cubed on top and a p to the negative second on the bottom. You could do it a couple ways. You could subtract the exponents and just get what? So it's 3 minus negative 2, right? Which is p to the fifth. You could do that. I've just found that a lot of students kind of mess up because what do you think a lot of students might do? They might just go, what, 3 minus 2, right? That's a very common mistake. You got to remember, you are subtracting. You're subtracting a negative. So if you can remember that, that's fine. Just go 3 minus negative 2. This is how I like to do it. I like to take that negative exponent, chuck it to the top, and what are you going to get? You're going to get a p what? Squared. You see that? See, I marked it off because I moved it from the bottom to the top. You still get a p to the fifth, don't you? Right? I think that's what most students like to do, so that's how I'm showing you how to do that. Is that all right? And then what about the q? Take this q to the negative first, chuck that to the bottom, and so that becomes a q to the first on the bottom. All right? And let's mark that out because we moved it, right? We took it from here to here. Let's see what we have on top now. I got a 3. What about the p's? P to the fifth. All right? And then the other stuff on the bottom, I got a 2. And then what else do I have? Q what? Squared. And that's it. It's not that difficult, is it? Just got to get the hang of it, right? Of taking the negative and moving it either from the top to the bottom or the bottom to the top, changing the sign of it, right? Finding out what the common factor is for all of those and divide that out evenly. Simplify everything when you're done. There you go. Look, never leave these problems where you have a p on the top and a p on the bottom. If you do, it's not simplified. You got it? If I had a q on the top and a q on the bottom and I circled that answer, I know I'm not going to get it right because the q's have to cancel out. I got to have either just, one set of q's on the top or one set of q's on the bottom, right? Not one on top and one on the bottom. You got it? Okay, because a lot of people will do that. They'll turn problems in, and you'll see like p to the third on the top and p to the second on the bottom, and then they circle it and say that's simplified. Well, there's no way that's simplified. All right, you can't do that. All right, I think I just have one more example. Let's take a look at this one. This is a little doozy. All right, there's a little bit. This is a little bit more involved. Same steps, though. Okay, there's really no different steps to this. It's just a little bit more stuff. So let's do this. Let's take everything here. You could do it a couple. I'm debating. I'll tell you what. Let's just do it this way. I was thinking about taking this whole thing, flipping it to the bottom, and taking this whole thing and flipping it to the bottom. That may be okay. I don't know. No, because you don't do that because this is already a positive right here. Well, if you multiplied it together, you would get a 3 to the... Let's just do it like this. Let's just take everything to the negative first and everything to the negative second. I think that'll be the least confusing way of doing this, okay? So here we go. So what do we get? We get 3 to the negative first, and we get x to the negative second, right? Because I took everything to the negative first power. Same thing here. This is another, 3 to the negative second, and x to the negative 10th. Everybody with me? Just took everything to the negative second. Do the same thing down at the bottom. So this is going to be 3 to the what? Negative second, right? Because you multiply the exponents. And this is going to be x to the negative fourth. Yeah, I think this will be the best way. Now, before you start moving stuff top and bottom, simplify the top first, okay, and simplify the bottom first before you start chucking things from top to bottom, okay? So let's do that right now. Look, I've got a 3 to the negative first and I got a 3 to the negative second. I've got the same base, so what do? You know what I can do, actually? Now that I'm looking at this, look, I got a 3 to the negative second on the top and I got a 3 to the negative second on the bottom. I just noticed that. What can you do? Right, that'll cancel out, won't it? That'll save me a little bit of work, I think. So what do I have now? I got a 3 to the negative first on the top. Let's do the x's here. So x to the negative second times x to the negative 10th. You add the exponents, it's x to the negative 12. All right, and on the bottom is x to the negative fourth. Now, we're going to have to move everything, aren't we? Because everything's got a negative exponent. So let's take this, chuck that to the bottom. So that's just a 3 to the first, right? Let's do this. Let's just chuck this to the bottom. Watch. If I take this and I put that to the bottom, that's x to the 12th. Agreed? Now, you could take the x to the negative fourth and throw it up to the top again, but why bother? Because look what I have. When I multiply these together, what do I get? I get x to the 8th. Everybody see that? See what I did? I took this, chucked it to the bottom, took this, chucked it to the bottom. I got 3 to the first, right? So 3 to the first is 3. X to the negative fourth times x to the 12th is x to the 8th. What's left on top? I took everything and I moved it. So what's left? A 1. And that's your answer right there. Getting the swing of it now? It's not so hard, is it? Basic rules, okay? They're just basic Algebra 1 rules. We're just applying a whole bunch of rules all together, right? And so we've learned the rules individually. It's just a matter of putting them all together and seeing how they all work together like this. All right, so we'll call that section 1.6b. All right, so I'll give you a worksheet on that. All right, that's good.